section 8.4 is our last trigonometric ratio, and that's the ratio of cosine. In relationship to our reference angle, cosine is adjacent divided by hypotenuse. And adjacent to the hypotenuse. So, in number 2, if our reference angle is angle B, this side is my adjacent side, and this side is the hypotenuse. So the adjacent side 7 to the hypotenuse 14 gives me a ratio of 1/2. Angle D is my reference angle. This side is my adjacent side. Is the hypotenuse. So the cosine of angle D is 6 radical 3 to 54. And this can reduce to radical 3 over 9. To find the approximate ratio for the cosine of 45 degrees, I get about 0.71. To find the value of x, I'm going to write an equation using the cosine of 60 degrees. Now, the reason why I'm using cosine is because in this diagram, they tell me that I'm looking to find the adjacent, and they tell me the hypotenuse. So the side that's adjacent to angle 60 degrees is x, and the hypotenuse is 6. Once again, if this is my reference angle, this side is the adjacent side, this side is the hypotenuse, so I will be using the cosine. All right, so we have to be a little bit careful about how we put this into the calculator because I want to divide all of this by the cosine of 63 degrees. So when I put that in, I want to group that 3 radical 2 So I need to close the parentheses for the radical. There's radical 2. And now I'm going to close the parentheses for that entire 3 radical 2. And I want to divide the entire 3 radical 2 by the cosine of 63 degrees. so I get about 9.35, rounded to the nearest hundredth. Then is walking her dog. The dog's leash is 12 feet long. And it is attached to the dog 10 feet horizontally from Remy's hand. What is the angle formed by the leash and the horizontal right here? What is the measure of that angle? So if I take a look at these two sides in relationship to this reference angle right here, I have the side that is the adjacent side, and I have the side that is the hypotenuse. So the adjacent and hypotenuse is cosine. But because I'm finding the measure of an angle, I need to use my inverse function. So cosine is the adjacent divided by, whoops, let's try that again. Adjacent is actually 10. And that's divided by the hypotenuse, which is 12. So finding the measure of an angle, I need to use my second function, cosine. 10 divided by 12 gives me an angle of about 33.6 degrees. Number 14, a ladder is leaning against the side of a house, as shown in the diagram. The ladder is 24 feet long, and it makes a 76-degree angle with the ground. The question is, how far from the edge of the house is the base of the triangle? So again, in relationship to this angle, we have the side that's adjacent, and we have the side that's the hypotenuse. So we're going to write the cosine of 76 degrees is equal to the adjacent side, call that x, divided by the hypotenuse, which is 24. Number 16, we have very interesting design of a roof truss. And because I am in the middle of building my own home, this takes on very special meaning because knowing some trigonometry has helped me to measure angles and lengths of sides in my construction work. So taking a look at this drawing, I'm going to, instead of answering all the questions, I'm going to find all the side lengths that I can find with the given information. For example, let's outline triangle ABH. In this triangle, I'm going to find the measure of x. Or actually, let's just call this the measure of AH, because we're going to be finding lots of different sides. So we're going to call this side AH. going to do that to find this missing side. I have my reference angle, which is 40 degrees, and I have this side over here, which is the opposite side, and I'm trying to find the adjacent side. So I'm just going to go back, and I'm going to remember, this is how I remember which trig function goes with what. I write down SOHCAHTOA. SOHCAHTOA. All right, so let's go back here. We have the opposite side, the opposite, and we have the adjacent. So opposite and adjacent is tangent. So I'm going to say the tangent of 40 degrees is equal to the opposite side divided by the adjacent side. We're going to call that segment AH. Round that off to 7.2. We're going to stick with triangle ABH, and now we're going to find the hypotenuse. Now, because I'm trying to find the hypotenuse, I can use either sine or I can use cosine. It doesn't matter because I know the opposite side and I know the adjacent side. So I'm going to select the sine function. And I'm going to say that the sine of 40 degrees is equal to, so I'm going to come up here, sine is opposite over hypotenuse. So 6 divided by, and the hypotenuse is what we're looking for. We're going to call that segment AB. We get about 9.3. Now, if this whole distance from here all the way down to there is 16, and from A to B is 9.3, I can now calculate the distance from B to C. So I'm going to start with 16, and I'm going to subtract 9.3, which leaves me with 6.7. Now let's take a look at some of the missing angles. So let's add in some of our 90-degree angles here. We have a right triangle here. And so in triangle ABH, if we have one angle that's 40 degrees and a second angle that's 90 degrees, then the third angle has to be 50 degrees. All right, we which means we can now find the measure of this missing angle because all three of these have to equal 180. All three of those are 180. So we're going to start with 180. And we're going to subtract the right angle, which is 90. We're going to subtract the 50-degree angle, and that leaves me with 40 degrees. And if this angle is 90 degrees, and we have the 40-degree angle above it, then that means this angle here has to be 50 degrees. And angle CGH is 90, so that makes this angle 40 degrees, which makes this angle up here 50 degrees. All right, so we now have all the missing angles, and so we can continue now and find some missing side lengths. For example, let's find the length from A to G. And this time, we're going to take a look at this triangle right here. Let's use a different color. Okay, so in this right triangle, and I think I'm just going to draw this right triangle over here so you can kind of see it. We have 50 degrees here, we have 40 degrees here, and this side is 6. So we can begin by finding the distance from H to G, and I really have an option here using either the 50-degree angle or the 40-degree angle. So I'm going to select, doesn't matter which one, I'm going to select my 40-degree angle, and I'm looking for the side that's opposite, and I do know the side that's adjacent. So I'm going to say the tangent of 40 degrees is equal to the opposite over the adjacent. So this side is about 5. So I think I'm ready now in trying to find segment CG. And to do that, I'm going to draw triangle ACG. And I'm going to place the values that I know. For example, I know that the hypotenuse is 16. And then from A to G is 7.2 plus 5 is 12.2. Now, because I have a right triangle, and I know two sides of the right triangle, I can find the third side by using the Pythagorean theorem, or I can use my reference angle, 40 degrees, and use sine, cosine, or tangent. So I think I'll just try the Pythagorean theorem. So for the distance from C to G, I'm looking for the square root of 16 squared minus 12.2 squared. It's a good review of the Pythagorean theorem. 16 squared minus 12.2 squared, and then the square root of all of that. and that gives me about 10.4. All right, so let's take a look at what we need to find and make sure we have everything in the drawing that we need. So we need to determine the length from A to B. A to B, yep, check. We need to find the measure of angle BGC. Angle BGC, and that's this angle right here, angle BGC. And we're going to check that off. The length of BG oh, we haven't found that yet. All right, so we need to find the measure of this length right here, BG. So, gosh, I can use the Pythagorean theorem again, or I can use my trig functions again. So if I want to find the measure of length BG, I'm going to try using the Pythagorean theorem another time. And let's highlight that triangle. Okay. And in that triangle, here's my right angle right here. I know the hypotenuse is 10.4. And one of the legs is 6.7. So if I want to find the distance from B to G, I'm going to take the square root of the hypotenuse, 10.4 squared, minus one of the legs, 6.7 squared. And it appears to be about 8. So we're going to change this into an 8. And so we now have BG, check that off, and everything else, I believe, is complete. Number 18, we again have a 30, 60, 90 in which we know the hypotenuse. And if I want to go from the hypotenuse to the short leg, I divide the hypotenuse by 2. And from the short leg to the long leg, I multiply the short leg by radical 3.